Switched on here. Okay, there's a button here. It was my fault. Great, good to be with you. I love the fact that the sun is shining, Richard. Thank you for arranging that. That's amazing. Yeah, just like London. Yeah, I have to say, when I came over on Monday, I did come from a sunny London and arrived in LA and walked out and thought, oh no, there's a bit damp. But this is good. We're back up to expectations. So for those of you that weren't at the VSF fall event in New York, in case you haven't noticed, I've actually changed allegiance. So I'm now CTO at Appear as of the day of the VSF event in October. So it's great to be with you. Now looking for my slides to change. Quick plug on the tea. I actually managed to come up with a cup of tea this morning, which is still warm. This is very good. So I'd like to shout out for Tina. So thank you for the tea. We really appreciate this. Just to say, I am doing a series of monthly tech podcasts now called Time for Tea with Andy. So if you're ever on Spotify and have got a hot 20 minutes spare, do go and check them out. And while I'm talking about cups of tea, I know it was called out a little bit later yesterday afternoon, but it was so exciting to see Mr. Lee Widdicombe in the room yesterday. Lee actually came all the way about 4 years ago from Canada just to have a cup of tea with me at my house in my garden. So Lee, it's great to see you, and thanks for coming. Right, on with the content of the presentation. So what I want to do this morning, and just to warn you, there's I'm actually going to be trying a remote live demo, which is always like raises the ante a bit, but hopefully will be a little bit of fun and just demonstrate and prove a point. And hopefully I've got some backup somewhere else that's going to be working with me on that. So, but I want to go through the technology piece first, give you the context of where I think we've got to in this area, and then we'll launch into the demo in like 12, 15 minutes or so. That's the plan. So. There's two slides that I've been using for the last 3 years non-stop. This is one of them. This is the DPP work that we did in 2020 during the first lockdown, which was just looking at the ways people are doing production now. And also shout out this afternoon, do come back, I'm sure you will anyway, but the second session this afternoon is a panel session where we've got 3 different end users talking about how they are using connectivity to actually do production at the moment. So that will be a useful gauge of what the industry is doing. But these were the 5 different key ways that people do production. The top one there is the traditional, everything's together, the acquisition, the processing, the storage, and the control is all co-located. Obviously, we're thinking more and more about that bottom scenario now, where we say cloud, and just again talk about cloud. I don't mean necessarily public cloud, although they obviously do very good offerings, but this could be any kind of compute infrastructure, whether that's on-prem, off-prem, private, or public cloud. This was and this is the other picture that I've been using at many of the presentations, and you'll see the main focus of this is saying actually where we're at as an industry is the camera acquisition is always going to be a linear process, sampling at maybe 50 or some strange 59-ish rate if you're over here. Hopefully in the future maybe 100 or 120 frames a second for pristine production. And then the microphone is sampling at 48 kilohertz or 96 if you're a purist. And then at the other end, whatever you're consuming your content on, it's being rendered back to a real-time stream for human consumption. And the same with the people involved in the production chain. But more and more and more, and several people have been talking to this in the industry for a while, the rest of that process does not need to be a byte linear process where everything is running smoothly like television has done for the last 90 years. There are a few key prerequisites that come into that. in terms of timestamps and origination time, etc., which we'll come on to a little bit later on. And I just want to give a shout out because Mr. Mayot's up after me, and he's going to be talking specifically about the GCCG work, and I'm hopefully going to link into that as we go through this. But fundamentally, we are on an inevitable journey to a more and more compute-based media production processing landscape. The only question for me is really in this, how much of that connectivity stays linear. I think in the mindset that we've done the ground to cloud to ground work so far, and the mindset most people are doing, we're staying linear until we hit the compute in the cloud, and then we're actually relinearizing as we egress there. Of course, we don't need to stop there. It may well be that actually in the future, the cameras themselves are put out a more non-linear, compute-friendly data flows, rather than the pristine 2110-21 flows that I've referenced on the top right there, that we've lovingly honed over the last few years. So what are the reasons, or why are we concerned about the way we do this compute, the interconnect within the compute world? Well, the main driver is the best of breed expectation of end users. So typically, most end users in the appliance world, up until this decade, have chosen their vision switcher, they've chosen their sound mixer, they've chosen their graphics engines, they've chosen their replay server tech, and generally those have been from different vendors. And the expectation, or the desire certainly of end users, as of the conversations I've had, is that they actually want to be able to continue to do that, to be able to do best of breed, but in a virtual environment. Now, obviously, that is entirely possible by going back to linear connectivity a la 2110-21 regulated flows between devices within switch fabrics to do that. So it's possible to concatenate, but there's lots of inefficiencies in doing that, and it doesn't give a completely joined up capability, and certainly doesn't optimize latency and things like that, which we'll come on to in a minute. So one of the other principles of everything that we're doing, I think, in broadcast at the moment is moving from the bespoke to the generic. We're seeing that in this inevitable move to compute. We're not really in modern infrastructure build using BNC connectors and XLR connectors anymore. Most devices now have native Ethernet interfaces, so it's IP out the box. So there is no bespoke broadcast connectivity per se. Although it's amazing how many people still do want some of that somewhere in their system. And that's true of every aspect of the way we're moving forward. So as I said, in just a few minutes, 20 minutes to be precise, Mr. Mayot's going to be up talking about ground to cloud and cloud to ground. And I just wanted to show this because the work and the demos we're going to do in a few minutes' time are not entirely predicated on this, because this is only just coming of age now. But we are actually very much in alignment and looking to align with the infrastructure and the constructs that GCCG has been putting together. So just a very, very quick look, and this is not telling any trade secrets, this is just stuff from public websites of these, and this is not an attempt to actually shortlist these as being specific things to look at, but just thought it would be worth commenting on some other industry initiatives that are happening at the moment, that some of which have already become de facto standards and the way of building ecosystems, and others which are on the rise, and others that are basically just backbone infrastructure. So just a few minutes just to talk through this. So SRT, I know it's almost 3 letters that we shouldn't even utter in a VSF world, and Mr. Ackerman has been very quiet for the last 30 seconds since I put this slide up. But I would like to say RIST is more fully featured than SRT, but SRT currently has by far the best market traction, would be my assessment of where we're at. with the technology, and I'm certainly advocating that within our company we support both of those moving forwards. Grass have been very active in developing AMP, which is their ecosystem of toolkit, and they've obviously got partners in, people working with them, pulling together to actually build a number of functions. NDI is something that in my outside my day job I love to work with. I use it a lot in doing production work that I do outside of my day job, and it's good enough to be used for lots of things. It's still a streaming interface rather than a native compute interface. It's got some quality challenges, it's got some scalability challenges, but actually it works amazingly well for the sweet spot for which it was designed. Matrox have done some great work, and although he's moved on now recently, Richard Cartwright was a great pioneer of the asynchronous and synchronous terminology, and I can even remember him presenting some of the vision of that like 10 years ago at EBU events. So he's been on that wheelhouse for a long time talking about that. AWS have obviously done some very valuable work with CDI, and they've put that in GitHub, and they've actually been quite active in the GCCG work, and have been sharing and making use of the foundation stones that they put in with that API. And then NVIDIA have been like repurposing the Holoscan stuff to actually make it usable for media. So that's just an example of different initiatives of different levels that are happening in the industry. Some of these are just usable toolkits that you can take. Some of them are things that will just subsume you as an application developer, depending on how you actually want to use it, but all worth being aware of. And they're all taking different takes on things. So the way we're actually interconnecting in compute, so assuming that you know, there's the de facto that you can use NDI and you can use 2110 as is to go in and out if you've got the NICs that can actually handle that. But basically, most of these infrastructures are tending to have either a streaming interface or a non-linear compute interface, or offering both. So on the left-hand side, those compute streaming interfaces are either UDP-based with or without ARQ, or they're TCP with some of the limitations that you've got there in terms of the way those streams are handled. So typically by default, NDI is a TCP flow. Obviously, a lot of the other work that we're doing, whether it's a 2022-2 transport stream, or it's a -7 TR07 JPEG XS, they're effectively all UDP. And it's worth saying that those, inherently UDP is fragile, and it's fragile in compute, especially in compute infrastructure such as public cloud, which is not been designed really for UDP traffic. It's 99.99% of what it handles is TCP traffic, unicast TCP traffic. So there is, it's not necessarily designed for that zero packet loss architecture that we're used to, which is why either 2022-7 or ARQ is essential when you're actually involved in those processes. One of the key things I think has been the aim of GCCG, and John will go to this in a bit later on, but also a lot of the work that other people are doing is abstracting the media processing functions from the transport layer. That's been a key aim. That's what AWS did when they released CDI. It was an abstraction, and several of the other vendors that are working on this are effectively doing a similar thing. And that's very important, because what we want to be able to do is to develop applications that are platform agnostic, and to allow us to do that, we need to have an abstraction that's suitable, that provides that integrity, that provides the time-bound data transfer that we need, but it is actually, we don't need to worry about that. Also worth saying that things like RDMA and associated technologies are really coming of age in terms of throughput, so actually interconnecting compute in a very high performance, low latency way is actually something that's working really, really well. And that's actually part of what we're going to be demoing here very shortly. So timing, I always have to have one slide on timing in every presentation I do. So one of the things that, what I will call the mistakes that we made in the 21 final version of 2110, even though it was, I think, in the TRO3 draft, so that we produced in VSF, is actually we don't track absolute time, origin time through the ecosystem. So we actually lose sight of origination time in the way 2110 is currently implemented. We've got some initiatives to try and compensate for that with the -11 work that's in flight at the moment. But it's been okay because it's been a linear flow of data. As soon as we go into a non-linear asynchronous compute world, timestamps become really, really important, because you have to know when things are flying around with no timing relation to each other. You have to know what they're associated with. So timestamps in the world that we're now in with non-linear compute is really, really essential. Latency. So one of the other frustrations of the 2110 implementation, as is done by most people, is people are dead scared of offsetting from start of frame 0 with tier offset. So whereas in an SDI world, a vision mixer for many of the key manufacturers maybe was 1, 2, or 3 video lines, now it's a video frame, because everyone feels that they need to realign to the next video frame because there is no trusted mechanism. Basically, tier offset of non-zero is not mandatory in 2110 receivers, so you can't actually say, I'm actually 3 lines late, now go. So there is some work there, I think, to be done in our linear world, but moving to the non-linear world, I think it's also important that as we look at this compute interconnect, most of what's being done, in fact, almost all that's being done at the moment, is integer frame related. And that's great, that works, it's a very nice thing to handle. But actually, in terms of looking at managing latency through a system, then actually what we did effectively with the striping in TRO1, with the 2018 version, the striping of the wavelet transform, as per the diagram at the bottom there, obviously the more you stripe, the more you get, the lower the latency you inherently incur. So that's a really important thing. Redundancy architectures is something in compute that's actually potentially a challenge, or that maybe there's a different mindset, and this comes back from the generic to the bespoke, or the bespoke to the generic, sorry, in terms of how do we actually handle redundancy? Do we use the orchestration tools that are available within the compute to actually reinstantiate flows when they come? In which case, can you cope with that hit of a few tens of seconds while it's rebuilt? Or do we do, in different availability zones or different compute instances, the typical rugged, resilient version that we would have done with our appliances? The jury's still out on that. I think there is probably some halfway houses between there as well that we've been looking at as well. So one of the things about compute is if you've got each function containerized, then scalability is really, really easy. So the demo we're going to do in a minute is lots of containers that are receiving flows, processing flows, and then separate containers to put that out. And those are actually going to be instantiated in the demo on different compute instances that are RDMA connected. There's also a challenge. One of the reasons in terms of the direct memory-based non-linear interconnect that we have, one of the challenges we have is the security and the isolation you need. And if you've got different vendors providing different software tools, the closer you come together to make the latency lower, to make it more seamless and holistic, the more challenges you have in terms of the security and the isolation between functions. So that's a challenge. Control plane, just wanting to say this is just a classic thing. Obviously, we're intending to use NMOS in the virtual world as well. So I think most people are effectively providing a proxy gateway between the way they're doing stuff within their engines and the NMOS interfacing. One topic that I've been discussing with Mr. Mayer over the last few months is ephemeral resources and NMOS. I think that's very important as we move to compute where stuff doesn't need to exist. So the stuff you want to use and consume in 3 hours' time doesn't even exist now. We're instantiating it an hour before it's needed. So actually, if you're doing setup, something like NMOS, which has no temporal concept, is a bit challenged because we actually can't really discern or configure, pre-configure, etc., stuff that doesn't yet actually exist. So ephemeral resources is something I think we need to do some collective work on as an industry moving forward. So just before we get to the demo, because I'm aware we've only got 9 minutes to do that in now, so a few key headlines. Compute is very powerful. So we've got to, I think, that sweet spot where compute is great, networking is great, storage is great, and those are of a scale now which allow us to do lots of really cool stuff. You can get very commonplace 100 gig and 200 gig NICs now into compute, which actually are very reasonably priced. And as an example, what I've put down there in that bottom box is just what you can hand off, assuming you're doing a multi-component production system on different compute. So if we're doing a 1080p 50, even if we go for 16-bit resolution and we don't try and do that crazy packing of 10 bits and stuff, then we can have 28 uncompressed HD flows, handed off on a 100 gig interface. Or if we want to do with full alpha as well, we can do 18. So, and the stuff does scale at this speed and work with the native IT compute infrastructure that we can utilize. So that's really, really important. This is a horrible diagram, and it's not mine. It belongs to David, who's actually going to be joining me remotely from the UK in a minute, who's put together this demo. It's very complicated, but basically what you can see is lots of little containers there. They've got different functions in. And then there is a bus, which is nominally, pseudo-equivalent to what we're talking about in GCCG land. And then we're actually pulling that feed up onto YouTube. I was actually going to have a live SRT demo running from here as well, but I thought as Rick Ackermans is in the room, I wouldn't dare do it, and I didn't have wrist available on my phone, so we'll forget that bit. So this is David. I did actually have a picture of him when he was dressed up as a pantomime dame a couple of years ago, but actually I thought I'll just use this picture from his LinkedIn profile. This is where I come from, on the East Coast in Suffolk, and so David is in Ipswich. I actually live in Felixstowe by the sea down the bottom there, so he's about 12 miles away from me normally. So I'm hoping he's going to be able to come on board in 1 second, and we can move to that. If you fancy just looking at what we're doing live on YouTube, scan that, because this is actually... I'm saying this in great faith, not knowing whether the demo is actually running at this moment, but if you want to grab it, of course, what I'm now doing is actually stealing all my Wi-Fi bandwidth for my remote connection here by having 35 people actually streaming it live. But I should have thought of that before I actually put that slide up. Very good. Okay. So, that comes after. The cup of tea invitation comes after. So Mr. David Atkins, are you actually there at the moment? Your video's not on. Your video's not on at this moment.
I've been very slack. There you go. Have I appeared?
You have appeared. Can we switch to the video now, guys? Here we go. So this is David Atkins, who is an industry colleague. He's been playing around with this technology for quite a while, and he's been doing some innovation under his banner as Frame in the last few months, and I thought it was worth us coming together. At Appear, we're also doing quite a lot of investment in compute technology, and we're looking at the synergies with GCCG and with the stuff David's been playing with. So I thought it was worth trying to do this. So David, do you want to share with us the UI into the system, just to show us what you're doing there?
We've got 15 people watching now, so,
15 people watching, okay.
I'm one of them. So
I can show the YouTube directly from here rather than it stuttering via Teams remotely.
I'll take that off there. So, right. So, as Andy said, there's a bunch of computes around the scene behind us. Interface into that is through a browser, where we just refresh that. So I have just loaded a configuration which, in theory, if all the wind was following in the right direction as it was just 5 minutes ago, I would now see some windows with video in it.
This is the classic. What? In the UK, we used to have a program called Tomorrow's World, and it was a live thing on BBC One, and almost every week something didn't actually work when they actually went to do it. It was a future technology program. I'm feeling this is a bit like this. I did see this working perfectly an hour ago, so I'm not quite sure what's happened.
What? Nothing is. Oh, come on. So, in principle, if you watch in 20 seconds on YouTube, we'll change the feed going to YouTube as the switch behind the scenes has connected to the other feed. Okay. So, and if I want to go full screen, I can take...
I'm going to pull YouTube up here then.
Yeah. Okay. Yeah.
So we can see this. So we've got a picture that looks relatively static at the moment.
Is that the outside?
This is.
I can't see your screen.
Oh, I'm not actually running, am I? That's what it was looking like a while ago. Let me whistle.
You need to hit live.
Okay,
yeah.
Here we go. So I think some of the key points about this is 1080 uncompressed 50p, and basically we've got multiple cameras running into compute instances. And if I'm correct, David, all of the ARQ receivers at the front end are actually running on one compute instance, then there's an RDMA interconnect to the other compute instance that's doing the switching. Is that correct?
So we've got one box doing all the inputs, then 25 gig RDMA into the switch. We then have two boxes. One is processing the output feeds, which is clearly sulking at the moment, for the cameras and the switching, and then we also have the YouTube feed, which is being egressed via a second box. So got three nodes involved at the moment.
I see what you mean about the boring view out the window. Maybe you should change back to the one of the other boring pictures. Yeah. I thought going out the window would actually be more interesting. It's going home time in the middle of Ipswich at the moment, so I was hoping you might be able to see.
I have seen 3 or 4 people walk past it.
Okay.
I'm waiting for someone to go past. So.
Okay. Oh, there was someone. We saw someone. Very basically, yeah.
Oh, right.
Okay. Okay. We need to optimize our production camera angles for future demos here. That's pretty boring. Okay. Okay. We're going back to there. So, any other key highlights? We've got another 30 seconds, David. You want to tell us about the demo and what we're achieving with this infrastructure?
So yeah, the RDMA allows us to have huge scalability. We can attach as many downstream nodes as we like. I think one of the earlier drawings showed the one input could be driving multiple processor nodes and multiple outputs. So if you're creating multiple different world feeds, you can do that relatively easily off this kind of approach, because it's acting. The networking is acting like your SDI switch used to.
Yep. Cool. Right, well, you never thought you would have a chance to see marbles falling down a little demo live from Ipswich, did you, as part of VSF this morning? I think that's a good, quick summary. Can we go back to the slides now for the front end? David, thank you very much for standing that up, and it almost worked as we expected.
Well, it'll probably start working the very second you go away. So.
Yeah, classic. Okay, so that's really where I wanted to get to. As I say, hopefully there will be some follow-up from John there to tell you about the initiatives. But I'm very excited that we're getting the technology to the point of view of supporting this, but also I'm hoping that we can actually help refine the GCCG work moving forwards as well as a result of actually a lot of the implementation work we're doing. So another call, do join me in the UK for a cup of tea. If you're over, do reach out like Mr. Widdicombe did. And thank you very much for your time this morning.